Yes, we are live. That's always the case, right? Because every now and then we seem to have problems connecting Zoom to YouTube and make sure that you can watch this session. But welcome again. I know that we just had a session yesterday. It was an amazing session about microservices and doing that in a functional style. But today we have yet another virtual jug session. Now I just have to make sure that I don't rehear the recording so it will not echo in my headphones. But hey, welcome. I'm glad that you're all here. And let's get started. I will just, I will just share my screen for a second. And hopefully, yes, you will see my slides over here. So welcome again to the virtual jug. As you know, we are the one and only virtual jug. What we do is we send you virtual content, but in this time, everybody does. Anyhow, we have, we still try to make sure that we have the best speakers with a broad variety of categories that they will present. So today we have yet a new session. First of all, my name is Brian. Yesterday was my colleague Laurie who was the one hosting the session. I will be your host for today. I'm Brian. I am working for a company called Sneak, but that's not important because I have to name them again because, well, they are our main sponsor at this point. They are the ones that helped us setting up this new, well, not so new way of streaming with Zoom. So thank you for that, Sneak. But more important is what are we going to talk about today, right? Today will be an introduction to data streaming, and it will be presented by somebody who is quite familiar within the virtual jug. I know he already had present a couple of times. Nicola Frankel will be your presenter for today, and nevertheless, I know that this will be yet an amazing session. But before I go to Nicholas, I will have to tell you a few things more, because first thing is that we have a small giveaway. At the end of the session, I'm allowed to give away 2 JetBrains licenses for their product. So thank you, JetBrains, for helping us out and for sponsoring us. That means that you have to be interactive. We are interactive on the Slack channel mostly. And if you want to deserve these licenses, I like to give them away to people that are interactively helping with the session. So keep asking questions on there. As I already said, we have a virtual jug Slack channel. Go to the live sessions channel, and on the live sessions channel, if you have any questions during Nicholas's talk, post it there. I will make sure that the questions will be redirected from the Slack channel to Nicholas, so I will not interrupt his flow unnecessary. If you have any other questions along with the virtual jug, please feel free to move them in an appropriate channel on the Slack as well. Please make sure that you share this session. Afterwards, when this session is done, it will be immediately online and available on YouTube. Share it with your coworkers, with your friends, with your family, preferably all of them. And well, let's make this user group even bigger than it is already. If you have any feedback, make sure that you can use that on the Slack channels, or you can ping us on Twitter, either the virtual jug or me personally, and let's have a conversation about it. If you have compliments, please put it out as loud as you can, as vocal as you can, of course, publicly. If you have some less positive feedback, put it in a private DM. But yeah, you know how it works, right? Anyway, again, thank you for being here. I will stop sharing my slides and I will give the word to Nicholas. Nicholas, welcome. How are you doing?
Thanks a lot, Brian. Thanks for your introductions. Thanks for your invite. Thanks for having me here, and welcome, everybody. I hope you are all fine, healthy, and well at home. So today I will try to entertain you with some introduction to stream processing. I'm Nicola Frankel. I've been there a couple of times at the VJUG. For more than 15 years, I have held very technical roles as a consultant in the Java Spring, Java EE ecosystem. And then a bit more than a year ago, I went to the developer advocate path. I'm trying to get up to speed in the distributed system area because I'm working for a company called Hazelcast, and Hazelcast has 2 main products. The first one that is called in-memory data grid. And basically, you can think about an in-memory data grid as a distributed data structure. So you can think about your map, but then you use the same API as the map, but it's distributed all over the network, and we take care of all the hard stuff for you. And the second is Hazelcast Jet, and since I will touch it in the latest part of the presentation, then I won't talk about it further now. So in this session, I propose you the following schedule. So why are we doing streaming? What are the approach regarding streaming? A bit about Hazelcast Chat, because I need to do a demo afterwards. And then how we can leverage OpenData. And then in the demo, since I will be trying to stream the map of all public transport in Switzerland, I will need to talk about a bit about what specification is around. Then if everything works, you will be super impressed with the demo. And if we have some time, of course, some Q&A. And if you have questions that cannot wait, of course, you are welcome to ask them on the Slack, as Brian mentioned, because for me, it's very hard. I don't see you. I'm just talking to my screen. So I don't know if it's super boring, if I cannot do jokes, because of course, if they are not funny, I will not notice it. If they are funny, I will not notice it either. So if you have questions, if we can make that more interactive, I will be very happy. So thanks, Brian, for taking care of that. So let's get back a bit in the past, and we're a time where data was stored in SQL databases. So when I started in the 2000s, 2001, that was the case. Data was stored in SQL databases. There was no other choice. I mean, it took a bit of time for data to evolve to this SQL model. And so the people were really wanting everybody to use a relational database. But even at the time, actually, we had needs and requirements that went a bit further, that required more than SQL. For example, you in general, if you work in retail, I did for some time, you have the manager of the supermarket that wants to have the sales reports for the previous hour, or the department manager. And so instead of taking the data out of the main database, then we make an extract in general. And in reporting, you have the same, if you have a bank account, which is the case probably for the most of you, then every year or even every month, you receive an extract of your balance with all the operations that took place. And again, you need to take the data out of the main database to somewhere where it can be easily managed. And the problem is that if you take the main database, well, the good thing is you have all the normal forms, and one of them mentioned no duplication. So basically, it's good because if you can change, I don't know, the address of people living at the same place in one place. It's good, but then it means that you are doing joins when you query the data, and a lot of joins mean that it takes a lot more time. And if you have indexes, and if you have constraints, all of that makes your data set more resilient, more consistent, but it takes a toll on performance. And then if you think about it, when you are doing transactions, you write and you read, but when you just want to read data, actually all those constraints, they are not very useful. And in that case, we could have the duplication. We don't care. We could denormalize the data so that we can access it much, much faster. And that has been the case for ages. We had SQL database and SQL database with denormalized data. And so actually, this ETL extract transform load has been part of our job since, I mean, again, at least for 20 years. Because you don't interact with the data in the same way for transactions or for analytics. And so using the same database is not a good idea because you will put additional loads on the main database for no reason. So you have this batching model. And this batching model like reads data from the main database, transform it. So perhaps doing denormalization, deduplication, all the stuff. Perhaps enrichment. Sometimes you take data from outside. In general, it's not the case, at least for this traditional batch. And then load it in, let's call it a data warehouse or like another SQL database with much, much less constraints. And I mean, again, if you have been working a bit in IT, like even for 5 years, for 3 years, for 2 years, I mean, you can. I'm pretty sure you're already familiar with batches. And the interesting thing about batches is they have two properties. They are scheduled. As I mentioned, the supermarket sales report is scheduled hourly. The bank closing statement is run either yearly. I mean, from like an accounting point of view, it's yearly, but for you, it's probably also monthly, and it takes some time to run. And you see where I'm headed, because again, probably if you have a bit of experience, you have been into companies where the time it took to run the batch was starting to get closer or even sometimes longer than the frequency. And if you have a batch that takes more than an hour to run, where you expect an hourly report, something is not great. Something bad is bound to happen. And in general, you know it a bit in advance, because like every week you see it takes a bit more time, and then it comes close to the limit, and then like all managers are starting to run around saying, oh, there is a fire somewhere, we must do something. Of course, there is this frequency issue. There is also the storage issue. Like once you've got all the data that is denormalized, you must put it somewhere, and it might take a big chunk of storage, or even bigger than you expected. And again, this might be an issue, and you can also see it's like in advance. You see the storage being like every week or every year getting taken more and more space, and again, it's not that great. Also, something that, of course, never happens in real life, the batch fails, because we are all good developers and all the data is good and everything happens like nicely. But sometimes I've heard that sometimes the batch fails during its run. So in order to handle some of the problem, then there were people thinking, oh, but these SQL data, one of the main issue is they are like single node. Most of the time, they run in master slave mode. So basically, there is one node doing everything, and then if something bad happens, another node can serve as a backup. But why? I mean, we are living in a world where we can have a lot of computers running in parallel. Why can't we distribute our workload over several nodes? And I mean, it makes a lot of sense, but then you must have dedicated frameworks for that. And Hadoop is one of them. So you must think first about the product, and then like have a workload that can be map reduced. It's possible. It's not for everything, but it's possible. In parallel, there were like experiments doing, but actually what the issue with these SQL databases, they are not meant to be just reads. They are meant to have transactions, to make the data consistent and a lot of stuff. And do we really care if we like have one line that is forgotten in our sales report for the supermarket. It won't change a lot. Of course, in the banking account, it will change a lot. And so again, there are some contexts in which it's better, but so transactions and all that stuff might not that be so important all the time. We try to be close to 100% of consistency, but if we are like 99.99, we are close to the truth, and that's fine too. And so like in parallel, we saw the rise of NoSQL databases. And also to handle the problem that sometimes your batch, not your batch, of course, but some batches fail midway, you can think about keeping the location of the cursor. So instead of trying to do everything at once, we will try to handle the data in chunks. And then we say, oh, this chunk has been done, this chunk has been done. And if we fail midway, then we start from the chunk that fell and not from the start of the batch. Of course, it opens a Pandora box, because what happens if we reload the batch, but since new data has been coming in? So that doesn't always work. Again, there is always some contexts where it's better suited and some contexts where it's not suited at all, but it's also a way to cope with failure midway. But I wouldn't say recently, because it's not that recent, but there is this like new paradigm called event-driven programming. And instead of having like chunks or whatever, like we have triggers. And actually event-driven programming is like super old. It started with a graphical user interface. So instead of polling every time that did the user click on something, then you just register a click listener, and when he clicks, you run some program. And like applying this event-driven programming on data gives way to this stuff called event sourcing. So every time that there is a change, you don't consider the state of the object, of the entity. You consider the changes that are applied. And basically, you can recreate the current states by replaying all events, which is super great. Of course, if you need to apply a sequence of events over like 10 years since you started your bank account, it's not going to cut it if you want the result now. So there are like strategies to cope with that. You make snapshots and whatever. But I mean, that's a way to cope with the fact that we can have data that is not only handled globally, but just as changing events. And if you know a bit about database internals, that's how, in general, database handle these things themselves. Like you have an append-only log in SQL or Postgres, and this log is read by the database engine itself to make changes to the state. So that, in fact, it's not only an implementation details, it's a natural way to handle that. And the fact that it's append only, it's very good, because it means that this log is order. This log is not immutable, but since you can only add stuff, it's very easy to keep a cursor. Then if two things happen at the same time, they will be written in the log one before the other. You won't have to think a lot about orders and all the stuff, the bad stuff about distributed systems. So the idea is, hey, let's make everything event-based, like really everything. And if you look at your data as event-based, then you start having a lot of benefits. Of course, you have also issues, but let's talk first about the benefits. The first is, since you don't need to load all these data in one batch, then it becomes memory friendly. Instead of having to have like, I don't know, 1 terabyte or 10 terabyte once per year, then you just need to handle the event when it happens, and the memory consumption can be as small as the biggest event that can be in the stream. Of course, afterwards, then, because you process one single event at a time, one single like chunk of data, then it's much more easily processed. And the second stuff is the first stuff, sorry, is that since you are doing like you are pushing the events, then you are very close to real time. Because one of the issue with the reporting, the analytics that I mentioned before is if as a manager you want to report every hour, then you need to wait 1 hour before having the analytics. And the issue is perhaps it might be better to get a report 5 minutes before. That might be a bit off, but you don't care that much. But at least you are able to take a decision earlier. And between 55 minutes and 1 hour, that's not the difference might not be that important, but it allows you to take decisions. For example, to have a sales on fish because fish today doesn't sell, and you know you have a lot of stock and this kind of stuff. Also, streaming allows something interesting. It allows to goes from the realm of finite data sets to infinite data sets. And if you have been playing with Java 8 streams, and I believe all of you have, it completely changed your mindsets. When you start reasoning in streams, you can do a lot. And basically, like streaming can be seen as a smart ETL. So you have your input stuff, you have your processing pipeline, which you can do the same exactly just as you would do in Java 8, like mapping or filtering or skipping or limiting or whatever. And then you have your outputs. And with that in mind, you can start like having some really, really interesting insights inside your data, because your stream now, you can ask it for some stuff that you couldn't before. Like you can have like windowing over the data, you can have chunks, and you can do whatever you want. So this helps a lot, as I mentioned, in decision making. You could have like really good near real-time dashboards. If you go to the e-commerce system, then every event or like buy events or change of pricing event or whatever could be pushed to the customer, so you can give him recommendations based on his interest, by also on your interest, like if you have a lot of stock, or if you have now sales on something, then you can push to him, sorry, or her. You can also handle this data by having, of course, machine learning, because everybody now is doing machine learning. And if you have also a bit old like me, you can have this complex even processing stuff. So it's an old paradigm. Basically, when you were doing enterprise service bus, where all the events of all software when going through, then you could derive some like complex business rule out of it, because then you could have an insight into every app. Well, at least that was the promise. And here you can have the same. The only difference is that an enterprise service bus was meant toward dispatching and messaging, where like stream processing is really like meant to have a stream. So just events going. At some points, however, you might want to store your events. You might want to store your data or not, but probably you won't. Then you might know about Kafka, which now is taking a huge place. You might keep an eye on its main competitor called Pulsar. I have no experience with Pulsar so far, but from what I've heard, it's an interesting competitor, especially regarding the operational side of stuff. And about Kafka, it's distributed, and the good thing is like you keep the events on disk. So basically, all the events, they are stored in like a topic in Kafka. They are, again, you have the same characteristic as before. They are order. And then the good thing is every client can connect on this topic and read the topic as its own pace. So it's not an issue where you have like very fast clients and slow clients. Every client can read at its own pace. It keeps its cursor, so you can replay the events or just keep following. And I mean, a lot of people are using Kafka for this kind of stuff. However, the problem of Kafka is also its main advantage is it's persistent. And the good thing with persistence is you keep your data. The bad stuff about persistence is you need to access the disk. And if you keep stuff in memory, it's like, let's say, 2 or 3 orders of magnitude faster, depending on which disk technology you are using. And sometimes you are not that wanting to keep your data. Like once the analytics report, the hourly analytics is done, it's not that important. Actually, once you've got the data in front of your screen, you can discard it most of the time because it's just for decision making. And so on the other side, there are like in-memory stream processing engines. You might know about the cloud ones like Amazon Kinesis, IBM Streams, Google PubSub. You might know about the on-premise one, just as Flink or Jet. There is one also that is very interesting. It's called Apache Beam, and it tries to be an abstraction layer. So to provide a unified API over some of the other in-memory processing engines. I think it's a very nice initiative. Of course, since there is no standard in memory stream processing, it's a very leaky abstraction, but I think it's worth mentioning. It's interesting. Anyway, among those in-memory stream processing engine, there is something called Jet. And Jet is just a single jar, so you can like embed it in your application, and you can start it like that. So that's what we call the embedded mode. It's also the modes that we propose for IMDG, as I mentioned in my introduction. But the good thing is you can start very, very fast and check how it works. The bad thing is basically your number of nodes is tightly coupled to the number of nodes of your application. And so in general, in production, you don't want that. So we have Docker images, so you can scale your Docker images independently of your apps nodes. And of course, if you can run them as jars if you want. They are like self-executable, so you don't need to have Docker, but in general, it's much easier to do that. And as Hazelcast, Jet also provides you a nice unified API that unifies streaming and batching. So if you are a bit confused, it's a bit hard to start with streaming. You can start with batching, do stuff as you are used to, and then with just one line of codes, because like with streaming, we've got some interesting challenges. We need to have timestamp, to have like ordering. Then you can use streaming very easily. Of course, we have an enterprise offering, but the basic package with which you can do a lot, that's with what I will demo afterwards, basically is open source and free. This diagram might be a bit big, but what you might be interested in is basically you have what we call sources. So we can read data from Kafka, from your IoT device, from IMDG, of course, from the file system, from database event doing change data capture, whatever. You can also output it to targets, so Kafka again, IMDG, databases, whatever. And then meanwhile, in the middle, then you have this distributed stream processing. So basically, you can do whatever you want with your streams, such as your Java 8 stream. What you can do is mapping, filtering. What did I forget? Mapping, filtering. I forgot one. Brian, help me, please. What are the 3 main operations?
Mapping, well.
Okay, just at the time I need you. Okay,
I know. But this is your cup of tea. I'm like mapping, filtering. I would say, yeah. I don't think you're going into reducing, but right?
Reducing, yeah, you can reduce all the time.
Yeah, so that's. But that was probably not the word you were looking for.
Oh, that's fine. Reducing is fine. And because you are doing streaming, as I mentioned, you can have like windows, so you can capture not only like single items of data, but you can capture a window. You can like handle the window. Just you can push it forward. You can have tumbling window. I mean, you can do a lot. And if you want to enrich, because in general you want to enrich, that I will demo afterwards. Then before starting your stream, you can like load your data from the database into the IMDG, and so you can access everything in memory, and it's very, very fast. Because again, like disk writing or disk reading is good, gives you persistence, but it's much, much slower compared to in-memory stuff. So the concept behind JET, we call it pipeline. So other stream processing engines probably have their own semantics. This just, in our wording, it's a pipeline. And basically, pipeline is a source or many sources, but in general, it's a source, a couple of steps that transform, filters, reduces, or window the data, and then the sink. And once you have that defined, that's static, that's just the processing, then you submit it to the engine, and then it becomes a job. And then JET, the JET engine, takes care of handling that job. So it's able to distribute it over first several cores on your machine, and then over the network over several machines. That's the benefit of that. And of course, some operations might not be parallel friendly. So you might say, oh, this one operation is not parallel friendly. I want it to run to a single node, or this is perfectly okay, like filtering, and then you can parallelize to your ORT's content. So this is, this is probably known to most of you. This is what you are doing when you are doing imperative programming in Java. You have this string, and you want to count the number of nodes, of words, sorry. So you split with white spaces, you count the number of words, and then you say, oh, if the count is null, then I start with 1, otherwise I increment it. But since you have been doing Java since a long time, then you are doing that with strings because it's so much easier. And the good thing with strings, you can read each line and understand what it does. And basically, you can have a much easier overview of what you are doing like that. So as I mentioned, JET runs completely distributed, so that in general, you avoid the fact that, oh, the batch stopped midway because I only had one node to execute it. So you distribute the load over several nodes, and if one node fails, then you kept a snapshot of where it failed and you can continue it. So that's what we can offer compared to, let's say, your own custom solution. So this is the JET code. It looks very, very similar to the previous Java 8 code to count the words. The only difference is here it might run distributed, and you have no clue about it. That's what I love. So here, for example, you have the data source that is read from, and then it's sent to multiple nodes. The mapping and the filtering can again be distributed. Then you can like accumulate it, then you can combine it, and afterwards every node and every core gets its result, and everything is aggregated into where you want to put it, database, IMDG, where you want. So now we have the basics of streaming, and we want to do some cool stuff with that. So we want data, and I could show you some private data, but that wouldn't be so interesting. So I want to show my demo with OpenData, so you can do it also at home. And OpenData is seems to be pretty hype right now. At least I know that in Europe, I cannot say about the US, but about Europe, there are initiatives in France, in Switzerland, in European Union, in Belgium, in lots of countries. So they are trying, governments are trying to open the doors of the administration and make the data open so that people, probably engineers, developers, or startuppers can use this data and give value to the data and bring something to the society. Just like open source is about code, open data is about data. But it's not that easy, actually. So here is some of the challenges that I faced, and you might be interested in hearing them. Like, it's about first access, the second is a format, the third is a standard, and the fourth is data correctness. So access. Well, data, as you and me probably accept the definition, is, wow, we have a web service, it's fine. Or, oh, it's a database, we can query it. Well, most of the time, administration gives you just a file, and it's not that fun. Then you have the format, because when you think open data means open format, and then it gives you a PDF, which is not that easy to parse. Or I'm not talking about Microsoft Documents, because that would be too easy. But so the second issue is what format do we have? So far, we wanted a web service, and we've got a file, and we wanted JSON or XML because they're easy to parse, and we've got a PDF. Not that great. And imagine we have XML, like for some, we are super lucky today. What grammar will be used? Of course, if you are using JSON, because JSON is so much better than XML, you don't have that kind of issue. You just parse it. But in general, you are happy to have a grammar, because then you can discard bad data as soon as possible, but it's not that possible. So we would like to have not only open data, but we would like to also to have an open standard over a domain, which is also very rare, sadly. And finally, the fun part, you might have be part of a data science team, or you might be a data scientist yourself, and you know that they're always bitching that basically, well, 80% of their business is actually removing bad data or understanding how is the data formatted. And here it's the same. That's part of my demo, actually. So the second and third columns are supposed to be hours. So hour, minute, second. And please, I challenge you, what does it mean to have 25 hours? I have no clue. So in that case, you are just trying wild guesses and saying, okay, let's try to understand it. Perhaps it must be capped at 24. Perhaps it's the day after. Perhaps it's just the day. You have no clue. So it's just try to be smart and at least to handle that data gracefully. My demo is about showing you the public transportation in Switzerland. So I handle everything up to the point where I wanted an open standard. And actually there is not a public open standard. There is this standard that is proposed by Google called General Transit Feed Specification. At first, I thought that the J was about Google. No, it's not Google Transit Feed Specification, it's general. So in a couple of words, it defines static model, and basically you have got a lot of files first to download. For example, the stops, because it won't it won't be very smart to send you the coordinates of a stop and the name of the stop at every call. What you want is you should already have it somewhere, and then it gives you only the ID of the stop, and you know, oh, this stop has this name and has those coordinates. And so you've got that for the stops, for the routes, for the stop times, for whatever. So you've got a lot of different files, and I won't go all over them because you can see there are a lot of them. And then you have got this dynamic model. So once you have like everything static inside of your company, inside of your information system, now you need to have the dynamic data. So you see, it's not that complex, but it's not that easy either. And your message will be here. That's the root. And you will have what is called the feed entity. And you see here, I have your vehicle position. And you are super happy because then it's just like a stop ID and everything is fine. So you can just say, okay, that seems like super easy. Let's do it. So I want to show you, to demo you what happens in Switzerland right now. So it's OpenData. It's I have found a site which offers the static files. I have found the same site which offers the REST endpoint. So it's a web service, it's JSON, it's nearly paradise. And then the first time I started to use it, then I got this model. And so I still have the feed message, I still have the feed entity, and now I'm looking, where is the damn position? Where is the position? And that's the issue. Is basically, it's a standard, but since, like, actually, I don't believe that trains and buses in Switzerland, they have a GPS chip. Probably it's forbidden by law or whatever. So they cannot do that. What they have is basically, they are saying, hey, here is the planned timetable, and here we will send you the difference between the like expected time and the current time. So we can tell you, hey, that this bus will be like 2 minutes late for this stop. So it will send you the list of all stops, and then you try to guess, oh, so I guess that this bus must be available at this time at this stop. And then you, between two stops, you will try to infer the movement. So the dynamic data pipeline would look like this. You will read the web service, so the big JSON, and you need to split it into different trip updates because you don't want to manage all that stuff. You want to treat this as a stream of events. Then you enrich it with the previous text file that you downloaded. Of course, you don't read directly from the text file every time. You put everything into memory. Then, of course, you have this fun stuff of transforming the hours into the timestamp, because my front-end developer wants in timestamp and not hours, which is fine. And then finally, you put everything into a key value store in memory, like Hazelcast NDG. And that allows you the following architecture. So I have like this JVM, like running Hazelcast chats. And what I will do, I might run another JVM that will first like loads every static file in memory. So it will send the job, and the job will read the text files and will put that in specific maps inside of INDG. And then on the second step, I will be able, once that is done, takes a bit of time. Once that is done, I will be able to start querying the endpoint. So I will send a new job to Jet to query the endpoint. And of course, it's not that easy, because then I have an issue, because the endpoint is protected, not only by saying, hey, you must have a notification token, but you shall not call it too often. So I cannot call it more than twice per 30 seconds. So I must like call it, do all my stuff, and then call it again to get more data, which is also fun. And then finally, because I need data visualization, I have this Spring Boot web application with registered changes to this final map. And so when there is a change, so when I receive a new change in the data, then I will like stream it again to my front end, and the front end will be able to put the points everywhere. So that requires a demo, and I will try not to do like yesterday, because yesterday I tried to do a demo and it didn't work. So the first thing that I need to do is I will start a local Jet instance. I can run it in debug. And if at some point I make a sudden move or something strange or sudden shout, it's because my cat is bothering me right now. It wants attention. It's not about you, it's about him. So so far is at my feet, it's okay, but it might do something crazy just as cats do. And here now I load the static data. So load static data.
Did you change your demo yesterday or not? Because I read your I
I
read your
made
tweet.
sure this morning that everything worked.
Okay, fair enough.
And here you can see that it's starting loading the data. So what I did this morning, and thanks for letting me explain it to you, I got, because the keep up with the static data because it's changed weekly. So in general, every time before a demo, I need to download the data and make it work again. And it's a couple of gigs. It's not that big, but it's not that small either. So the first job is basically what I'm doing right now. And I'm sorry, but though it's the 25th birthday of Java, I'm still a Kotlin fan, but I will explain it to you, no worries. So this is my main methods. And basically what I'm doing here, oops, I'm like getting a hold on the Jet instance, and then I'm sending for each job in the pipeline, I'm sending it as a new job. And the pipeline actually, those are all pipelines. So basically, because I'm super lazy and I try to show off, which was perhaps not that great an idea, like I have one job for each file that I try to handle in the same way. So this is a job. And it's defined as a pipeline. So it has a name. It has what I call JSONify because the file is text file. Here, this is a text file. It's not that fun. And I want to make a JSON out of it because I want to have a PK to be able to get it later. So for example, if I show you the stops, I want that to be the key. Because again, I'm storing everything into a key value store in IMDG, and this needs to be the key. So I need to be able to like extract the key, and also it's better if I can make the rest a JSON object out of the rest. Then I have sometimes need to merge it because, for example, here I have the stop ID. That's my like one of the root entities. But if I have a route here, then you can see that not this one. Here I have the root ID. Here I'm using the agency ID. So this one references the agency here. What could be done is I could store everything raw into the IMDG. But again, my point is when I want to access the object, I want to be as fast as possible. So I want the object inside the memory to be as complete as possible. So I don't need to get multiple checks. So I build the object that I want directly when I'm loading. And then I must check if it's ended. No, so it still continues. It takes some time, let's say. And then I have this, what I call stream dynamic. And here it looks a lot like the same. I still have this pipeline, sorry. I'm able to handle mock data just in case I am doing my demo in a place where I don't have internet. And basically, I will read from the service. Because I'm doing streaming, I will add some timestamp, and the timestamp is the timestamp of the JSON itself. So I will need to extract some JSON fields. Then I will flat map over the split payloads. Now my cat is coming. And then I will be enriching each item going to different maps. So first I will, enrich it with the trips, with the stop times, with the stops, blah, blah, blah. I will also dump just in the log, just to make sure that everything works. Of course, in production, you should be very careful with that. And in the end, I will write to the IMDG. And now I'm still doing something. So I will show you the web port, which the web port is the easiest one. So this is, sorry, this is a WebSocket application. So I have a stupid update controller that basically at the beginning will like subscribe to the IMDG. So every time there is a change, I will get an event. And when there is a change, I will send it to this message broker. Just at the beginning, I was killing my front end. I was killing the JavaScript front end. So I have put a small sleep just to allow me, okay, I'm not very up to date, but since I'm not a JavaScript developer and I don't know how to do back pressure between the front end and the back end. So I'm doing this kind of little stupid trick, but I hope it will be good enough. Still working. Perhaps I have some questions meanwhile. Do you have some questions from me, Brian?
Yes, I do have a couple of questions. Let me get to the right channel. Let's start right from the beginning. You were talking about batch processing in the beginning of your talk, right? And somebody was asking, well, wouldn't it be easier to if that batch takes, for instance, a batch that needs to work with data from the last 24 hours, and that might take up more than 24 hours to get that batch done. Would that be easier to parallelize to do these things in parallel?
That's a very good question. That's a very good question. But the problem is that most legacy systems, they cannot parallelize that. Say only with Hadoop, you started being able to parallelize data processing. So yes, of course, you can do that. That's the first step. But it's only when you have enough tooling to do that right, which is not always the case.
Definitely. Is Hazelcast Jet a bit similar to Kafka Streams?
So yes and no. So the concept is similar. So you understood perfectly. But the difference is that Kafka Streams relies on Kafka, so relies on the topic and everything. So every time you do this transform, you write it into a new topic, which means, again, you are persisting your data. And it has a pro, it's persisted. It has a con, you are slower than if you are just processing everything in memory. So there are use cases for using Kafka Streams, and there are use cases for using Hazelcast Jet. Now I can follow, it has finished loading the static data, so I can stream the data live. So now I will be calling the REST endpoints. So I send the job has been sent. And now you can see here that I start receiving data. So I can go on my browser, I can refresh. I hope it works. No, of course, it never works on the first time. So I will just try to close it. It's a bit long. Local hosts. Of course, I didn't start the web application. That's fine. That should be better now. If you start the web application, it's always better. So now my web application has registered on Jet. And nothing happens. Of course, that would. So I will stop the web application and start it again. Ah, no, it starts. I receive it just now. Yes. I was a bit stressed. I'm always a bit stressed. So here you can see that it's populating the map from the data it receives. Of course, as I mentioned, it doesn't display everything at once. Otherwise, my client would be overflowed. The red lines are trend lines. The green lines are bus lines. And every little marker is basically a trend or a bus or something that should be moving. So at this scale, you cannot see a lot. But let's go to Lausanne, for example. And let's get a bit closer to... So here, like a bus line, and you can see that there are stops. So this, and if you come a bit closer, normally there should be the line number on the road. So the problem right now is instead of going around like it follows, I just have like stupid interpolation. So I just like draw a line between two of them. Let's see, this one is not moving. Perhaps it's, yes, this one was moving. So let's keep the one moving. Here it doesn't follow road. Again, perhaps a bit of front-end issue. And here you can see everything that is happening on the map. So it takes a bit of time because I have a lot of data points, so they must refresh. This one seems to be moving much faster. So the JavaScript engine on the front end must keep up with everything. But you can see that some of them are definitely moving a bit faster than the others. And this is like super nice data. Again, like here, I have something that cross the lake. It shouldn't happen because it should follow the trend line, which is not the case right now. But otherwise, you can have the correct data again because of interpolation. Then the location might be off by a bit. But otherwise, you can see all of public transport in Switzerland at the moment. At least what I have is what is planned, and I receive the delta between what was planned and the current situation, and then I make my own computation and decide, hey, it should be here. So please keep the questions coming. Now that it works, I'm much more relieved.
Thank God you're relieved. I mean, it looks perfectly great. One of the questions, of course, is this demo code available somewhere?
Yes. So if you are a patient enough to wait until the end, I always put the GitHub repo on my last slide. So it's an incentive to stay until the end.
I completely agree. So yes, at the end, the code will be, or the GitHub repo will be announced where you can try it out yourself. Does Hazelcast Jet support or help with things like back pressure?
Like if you go outside of Jet, not, but inside, yes.
Okay, fair point. There was a question, and I'm not familiar with this thing. Does Hazelcast has directed acyclic graph kind of workflow? And I'm not familiar with it.
That's a very good question. So at the beginning of the Jet job, you will see the DAG printed out for you. So in one of the ancient API, you had to create the DAG yourself. Now it's generated for you. And of course, as I mentioned, like some operations are not distributed friendly. You want to keep this operation on a single node. Then you can say, oh, like this one should be kept on one single node. So parallelism is one. You cannot distribute it. You cannot parallelize it. Otherwise, for every node, node in the DAG, you can choose your parallelism if you don't think the default one is good enough. Okay. And I think the default one is the number of cores on the machine.
These questions always come up, like how do you compare Hazelcast Jazz with things like Apache Beam or Spark streaming, for instance?
So
Can you?
I don't know about Spark streaming, but as I mentioned, Apache Beam tries to be an abstraction over a different in-memory stream processing engine. So it should be seen as a kind of Spring. The difference it's much more leaky than Spring. So basically, I think it's a very good initiative. It's a very good idea, but I'm not sure of the current acceptability of what you are trying to do. But if you are trying to like not be implementation dependent, not to be vendor locked in, then it might be a strategy.
Mm-hmm. What would be a specific thing for Hazelcast Jet to jump out? What would be a use case in general, in your opinion? Does it need to be in a memory thing?
It's not enough to display every public transport on a map. No, we are.
No, but people are asking themselves, okay, should I use one or the other, and how should that's more or less the discussion that's going on now on the live stream, because we have a bunch of these. Well, from the outside, similar looking technology. So I think it's a fair question.
Actually, what we are very good and very deeply interested in are check of financial transactions. Like you have a transaction for your credit card, and you want to give feedback like with as much accuracy as possible, with as fast as possible to the shop, whether it's a valid or a not valid one. And for example, we mentioned Kafka streams, then it would be feasible from a technological point of view, but not from a business requirement point of view to use persistent technology in that case, because, well, once you've decided, in general, you don't care that much about the result, but you care to be very, very fast. So you would load, for example, a lot of data into your Hazelcast IMDG, and then run the stream, and the stream will check the different, I don't know, data points or the location, like this kind of stuff, and decides very, very fast whether, yeah, it's a valid transaction or it seems to be a not valid transaction.
All right. How can we preserve ordering while processing the data through Hazelcast?
Well, it's not through Hazelcast. It's a real problem in every discipline. If you are interested about that, you should check our JET documentation. There is a section on, it's called watermarking, and it explains all the details in what we are trying to do, how we are trying to achieve that. So it can be a talk in itself.
Okay, thanks. For now, I have a few questions for up to the end. I don't know if you have anything left.
So I'm happy my demo works. So now I can stop it, of course, because everything in life is transient. And let's finish the few slides that I want to show you. So I try to show you that going from the old batch legacy model to streaming has a lot of benefits. Of course, it's not like unicorns and rainbows, but if you can leverage it nicely, then you've got a lot of benefits. And if you couple that with OpenData, then you can truly achieve like very, very interesting stuff regarding, yeah, it can be like fraud detection, can be data visualization, can be a lot of stuff. If you go the OpenData way, but I'm pretty sure if you also use your own private data, it will be the same. Be very, very careful how you manage the data, because you must, like, on every step, on every transform, on every filter, on every, like, really literally every step, you must take care that it doesn't explode in your face. So be very, very defensive regarding your programming model. And so thanks a lot for your attention. You can read my blog, which I publish weekly on Sunday evening. You can follow me on Twitter. It's always a nice ego boost. So if you do that, I will be happy. My employer will be happy. You can read about Hazelcast Jets on this side. You can check about the OpenData Swiss if you are interested. You can read about the GTFS, how it's called, fit specification. And as was asked before, here you've got the GitHub repo. So please try it, use it, give me feedback, and even like contribute to it, because I've open issue, but I'm not a front-end developer. I suck at front-end, and I would love to make this demo even better.
Yeah, okay. I'm not a front-end developer either, so. How many? If we looked at this demo that you were showing, how many nodes was it running on?
One single node. Because I mean, if I have one node on one machine, it's good. If I have two nodes on one machine, it doesn't bring much, apart from showing off. But no, I only had one node.
Okay, fair enough. Let me look if there is another interesting question that is not basically already answered. I guess not. I think we are right through it. So let's first of all, let's stop sharing screens. That would be great.
Perhaps I can show sorry, I can put this one might be interesting, so that people can.
What we can do, maybe you can do it yourself, to copy paste this in the live channel, so we can so people can just click on it.
What I will be doing, I will be putting that on SlideShare and tweeting it, and if people are really nice, I will also put the link to the SlideShare on the slide.
Amazing. So yeah, sharing the slides. We have the demo code over here as well. Thank you. I appreciate this very much, Nicola. All right. So that makes basically the end of this session. It's locally here almost 10 past 7. A lot of reactions, and I will put two lucky people out. I will point two lucky people out on the Slack channel in a moment, who have received who will receive the JetBrains voucher for a new license. Just use them right away, because normally they are the time you can use it are limited, but they will basically, if you already have a license, they will just extend it for another year. So that's a great one. Anyway, thanks for watching. Keep an eye on the agenda for the next couple of sessions. At this point, we didn't have anything scheduled yet, but it will be soon, because in the meantime, I was talking to a few of the admins on new sessions. For this time, I want to thank you, Nicola, for this great demo. I loved it. It was
Thanks a lot.
It looked great, and even with a little bit dodgy internet, it was good enough to follow it and to get the essence of your talk. So thanks.
I will stay a bit on Slack, so if attendees have more questions, then I can answer them live, if I can, of course.
Yes, of course. So if you have any questions, even if you are looking at the recording, maybe you're looking at the recording right now, Nicolas is very active on the VJUG Slack channel, so you can ping him if you have any specific questions on this talk he just gave. So for now, I want to thank you all for coming. I want to thank Nicola for Nicolas to do this talk for us. And for now, I want to say see you all later. See you at the next session. Bye-bye.
Thanks to everybody. Have a good evening. Stay safe.